Welcome back. Today we're going to be looking at slope and lines and getting started with our linear functions. So let's go ahead and get started. It's going to be super fun as we look at slope from points, forms of slope, all the different types of forms of lines, linear equations, slopes, and the normal things that we see as we do rates of change. So let's get started with our creed. Remember, 99.9% of people who don't say the creed don't get 100 in the class. Today is a new day. I can read and remember well. I can develop my viewpoint and apply it correctly. I have eyes to see, ears to hear, and a mind to understand. It might not always be easy, but it is always worth it. All right, let's get started. So we're going to look at slope today. We're looking at this thing that you've seen so many times. And honestly, every time I write it, I like to write all these things and more. If you can think of more, like one that somebody in class thought of is like, well, couldn't we also write f of x2 minus f of x1 over x2 minus x1? And I was like, yes, you could definitely do that. It's pretty darn similar to that y1 right there. But anytime I think the word slope, I want to think all these different things, right? Because it's all kind of the same idea of your y's change as your x's change, right? We talked about functions on day one, where a function is like taking a set of numbers, funneling it through a system, and turning it into another set of numbers. Well, slope is like taking a set of numbers, funneling it through a system, and seeing how much it changed compared to how much the numbers changed. So let's get started. Without further ado, first thing we're going to do is look at these numbers and label them, right? We're going to label them x1, y1 every time, and x2, y2. And then we're just going to hit up that formula that says y2 minus y1 over x2 minus x1. And we're going to be really darn careful. We're going to use I am going to beg you, implore you to use parentheses every time, even if it's a positive number, so you don't mess up what happens. So it's a 4 minus a negative 1. Even though that 4 is positive, I'm putting it in parentheses. Negative 2 minus a negative 3. I'm begging you to use all 4 parentheses every time, so maybe you can not mess up a negative sign, which is super important. So that's 5, because remember, minus a minus turns into a big old plus sign. Minus a minus turns into a big old plus sign. So we've got negative 2 plus 3 is positive 1. So our m equals 5, right? No mistakes there? Sweet. Let me know. Yell at me in email if I did. So that's how to find the slope of a line passing through points. Let's use that formula, that main formula, y2 minus y1 over x2 minus x1, which is to say the change in y, or how is your y value changing as your x value changes. It's like a comparison of change, right? All right. So your slope defines your line, right? So as your as slow as we can say this, as your x value gets bigger, we'll see those little arrows where your x value is hopping over. As your x value gets bigger, so your x value started here, right, on this blue dot, and the x got bigger. What happened to the y value? It got bigger, right? It went up. The y value got bigger as your x got bigger, so your slope is positive, right? So you got positive, negative, constant, and then this big one undefined, right? The way I like to remember that is going upstairs, right? If you're a guy and you're running up this thing, that guy is running upstairs, right? He's running up a ramp. Going downstairs, if you're a guy and you're running, you're probably going to have to be careful or you're going to fall, right? Running downstairs, so you're running faster. If you're a guy and you're running right here, right? Boop. How's that? That's pretty normal, right? That's constant. That's it. Another way you can remember that is see that flat line right there? Think about a Z just starting right there. 0. And then right here, if you're a guy and you're running, wait for it to, yep. If you're a guy and you're running and you're on this, you're dead, right? That's not even, I don't even know how to explain that. Like, he can't run there. He's just falling, right? Another way to think of that is this U starts right there. Undefined. Okay? Awesome. Well, here we go. Let's hop into our first line. The point slope form of a line. So we just found slope from 2 points. Now we can find a line from that slope. So we're going to use this formula, which is a weird old formula, but it's pretty common. And we're going to plug in some numbers. So our formula talks like this. General y without a little number, minus a specific y, 1, equals slope times general x minus a specific x, right? So I'm going to go through my equation and label. Here we go. We got our x1, y1 just like last time. And this m equals 4 is your slope, right? So we plug all that stuff in and we get y minus, like I said, I'm going to beg you to use your parentheses every time you plug one in, equals 4 times m, oh, not m, x minus negative 1. Y minus 3 equals 4x plus 1. And then it says express them in standard form and y-intercept form. Ooh, so we got to do a little bit of our algebra from the first unit where we got to move stuff around. So let's get in slope-intercept form first because we're like 2 steps away. So watch this. Boop, boop. End up with y minus 3 equals 4x plus 4. I'm going to add that 3 to both sides. And I'm going to end up with y equals 4x plus 7. That is our slope, even though we haven't defined it yet. We're about to in like 2 problems. That is our slope-intercept form. So then we might as well go up here and say this first form we plugged in is our point-slope form. And then we're going to go ahead and get our third form by putting everything on the same side except for 0. So watch this. If I move that y over, so let me take this form up here. Y equals 4x plus 7. Move that y over so we get 0 on one side. And we are going to be left with 4x minus y plus 7 equals 0. And that is my boop, 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 general form. Or does it say standard form? It says standard. Sometimes I've heard general, sometimes I've heard standard. General form, standard form. All right? Okay, so let's think through what we've done. We've taken 2 points and found a slope. Then we took a point and a slope and found a line. So the next step, if you took 2 points and found a slope, and then you took a point and a slope and found a line, what you already should be thinking or know how to do is, wait, if I can have a slope and a point and find a line, then I could have 2 points and find a slope, and then one of those points and a slope and find a line. I know that's a lot of words, but let's just see what happens. So watch this. First step first. It says find a line from 2 points. Okay, find a line from 2 points. Well, here we go. y2 minus y1 over x2 minus x1, right? Same old formula. Let's go ahead and label. Label x1, y1, x2, y2. Plug them in with parentheses every time. I don't care if it's positive. Use those parentheses, please. I'm begging you. I'm not going to count it wrong on your test, but you have such a better chance of getting it right if you use the parentheses. Negative 2 minus 4. So that's going to give me something like 9 on the top and negative 6 on the bottom, which is going to be something like negative 3 over 2. And what is that? Did we find a line? No, we just found our m, right? Or our slope. Okay, well now we have slope and we have 2 points. It doesn't even matter which one you use. You could use either of the points. We'll end up with the same thing, but we're going to plug them in and get the equation of that line. And we're going to go y minus. Well, which one do you want to use? y1 or y2? I don't care. Use whichever one you want. Y minus. I'm going to go with 1 just because, we can. Y minus negative 3 equals, where's our m? It's right over there, negative 3 over 2, right? Times x minus, and we got to use the same one, so because I used y1, y2 is gone, right? X minus 4. And I think it says just find the equation of point slope form, so we're done. We don't even have to do our distribution or anything like that. We can just leave it like that and be happy, right? Now later, if it says like put it in the standard form or whatever, you might have to do a little bit of arithmetic and moving stuff over, but you can do that. I trust you. All right, here's the definition of slope-intercept form, and the reason they give us to us later is because the skills you needed to do it you already had in the algebra and moving stuff across the line. But now what we can do is graph it. We can graph it by looking at what these things actually mean when we get it in that form. So that m means our slope, right? Or all those words, rise over run, y2 minus y1 over x2 minus x2, change in y over change in x, average rate of change. All these things are the same thing as slope. And this b is our y-intercept. And that is, make a big, big star. Graph this first. Graph this first. All right, here we go. So they give us a line. I'm going to make it a little graph so we can kind of have something. And like I said, we're going to graph this first. So we got our y-intercept first, right? Plus 2. Well, 2's a number. 2's not a y-intercept. 2 is a number. I'll get on to us till the day we die. 2 is a number. 2 what? 2 desks? 2 t-shirts? I don't know. 2 is not a y-intercept. What is a y-intercept? 0, comma 2, right? Awesome. So I'm going to go up 2 and plot that point. And then I'm going to grab my slope and say m equals negative 3 over 2 equals rise over run equals down 3 over 2. And that's how I always write that, right? So watch this go down 3. I'll do this 1, 2, 3. That's my down 3. And watch this go over 2. 1, 2. Over 2. So where does that put that point? That put that point right there. And then we just draw our line. All right? Not too crazy? Draw those arrows at the end of it so we... Oh, not that. That's bad. What did I do? Boop, boop. Draw those arrows at the end of it so that we know it goes on forever. And you're a happy camper. That's graphing a line. All right? Okay, let's talk about some quick acronyms real quick, and then we're pretty much done. We're going to talk about some quick acronyms. All right, horizontal lines and vertical lines. So if you can remember this acronym, it doesn't stand for anything. There's no good word to remember. But if you can remember this acronym, I'll do it in big, bold letters. Big, bold, red letters, because I want you to remember it. If you can remember, where am I going to put this? Up here. Hoy, bucks. Like I said, no good word. Just remember those two little short nonsense words. Hoy, bucks. Okay, you ready? Where hoy stands for, here, I'll do it vertical. Where hoy stands for horizontal. The 0 stands for 0, which is your slope. And the y stands for y equals. All right? So then what does VUX stand for, right? Well, you can probably opposite all of those. VUX stands for vertical. U stands for undefined slope. And the X stands for X equals. And that'll tell you the form of that line. All right? So then that makes our life really easy because we see y equals 3. I go and pick one of those. Which one has the y equals? Horizontal. Boom. I already know it's a horizontal line. So I can just draw my horizontal line and say, where do I got to put that line at? 1, 2, 3. Right there because we have a number equals 3. Boop. Just place that horizontal line right at 3. Draw your arrows and you're good to go. And that's what hoy VUX helps you do. Is just look at it right away and know which one's which. So let's try this one. X equals 2. X, whoop, hoy VUX. VUX because it has an X, right? So X means VUX. So that means a vertical line. So guess what I'm going to do? I'm going to go over to 2. Boop. And I'm just going to draw my vertical line and be done. Literally that easy. It's not trick questions. These constant functions and undefined functions are like gimmes. They're like free questions on the test. All right? And if you wanted to define it, you could say that's undefined slope. And you could say this one is 0 slope, right? Worth noting. All right, we're almost done. This is awesome. This is not too crazy. All right, so now we've got the general form of a line. I know we've already solved for it, but this is just expressing what it is. This is where we were talking about the difference between standard and general. So this one, what they've done here is they've just put the constant on the other side. You wouldn't lose points if you put the constant on the same side and set it equal to 0, because that's what we do most often. But if you do take note, they do put the constant on that right side right there. So what they're doing right here is they're giving us general form, or that's not even general form, that's moved over once, right? And they're saying, hey, find the slope and find the y-intercept. And you know how we do that? We get it into y equals form. So let's just do one of these, even though they're pretty reviewy. First thing you would want to do, you're trying to get y by itself, right? So the first thing you want to do is move that 4 over. 3x plus 2y equals 4, right? Second thing you want to do is move those x's over. Negative 3x plus 4. Third thing you're going to want to do is divide by 2. And you're left with y equals all that mess divided by 2. So negative 3x plus 4 all over 2, which is y equals negative 3 over 2x plus 2. And so there's your slope and there's your y-intercept. Cool? Make a note, what is the y-intercept, just so we can get good at writing it. It's not 2. Don't say 2. Say 0, comma 2. A lot of tests, would you be wrong for saying 2? No, but I want your brain to automatically see that and not think 2 what? 2 couches, 2 mirrors? No, 2 shifts upwards on the vertical axis, right? 0, comma 2 is so important. All right. Last but not least, sometimes it's just a different way to graph. It doesn't change very much. It's just saying, hey, sometimes by graphing, you can just set things equal to 0 and solve. So what they're doing saying is, hey, we can find the intercepts first. Sometimes that looks easier. You can just find the intercepts first, and that's okay. If you don't like that, convert it to y equals and solve, because you know how to do that because you're smart, competent, and you're able to do that. But if you want to, what they're saying is just plug 0 in for x. You plug 0 in for x, you do a little bit of algebra solving. 4 and 0 turn into 0, right? So now you're left with -3 equals +6 because we moved that 6 over. Y equals -2. Oh, look at that. That's a point. Those two things work together to get you 0, -2. Not too crazy. And they're like, hey, now plug it in for y. See what you get. I'll do that over here. Boop. 4 times x minus 3 times 0 minus 6 equals 0. They're saying that 0 takes it out, right? You're left with 4x minus 6 equals 0. 4x, move that 6 over. X equals 3 over 4. Oh, I was going to reduce it and then I didn't. X equals 6 over 4, which is 3 over 2. That's not 3 over 2. That was terrible of me. What is that? That is not 3 over 2. That is the point 3 over 2, comma, 0, right? And then what they're saying is, hey, sometimes if you want to graph it a little differently, you can take those 2 points and go boop, 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 boop. There's that red point. I'll make it red. There's that red point. Go down 3 or go up 3 over 2. There's that blue point. You can draw your line. Boop, 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 boop. And that's just a different way to draw the line if you don't want to do the rise over run counting method. All right? Notes and practice retrieval. I think this is pretty cool. What are the things we talked about? I'll give you the type. I'll retrieve the type. You retrieve the equations. Without looking backwards, we're going to try to say everything we learned today. Well, we learned point, slope, form. Can you retrieve the equation without looking? We learned slope, intercept, form. Can you retrieve the equation without looking? What else did we talk about? Ooh, see, no, I'm not even messing up. We're talking about general form. Can you retrieve the equation without even looking? And then the 2 other things that I really wanted to mention, that's why there's 5 things and not just 3, is line from M and point. And then the second thing is line from point and point. If you can do those 5 things, that's my retrieval. If I could retrieve those 5 things and then go and retrieve a problem about each one and make it up and solve it and feel super confident, then I'm good to go. I know this section. I'm home free. That's kind of a little review on what we talked about, that retrieving practice, which helps you learn and not just copy. All right, thanks for watching. Make sure you're tuning in more often. Make sure you're practicing for your tests coming up. Make sure you're getting ready and learning all the material that we've learned in the first semester and in this one. I'll see you soon. See you in class. Feel free to reach out if you have any questions or if anything doesn't make sense.